and we have the system timer. So system timer, it's actually system tick timer. It's called systic. You will see this keyword if you look at the manual. Systic. It means it's a system tick timer. So it has only one 24-bit countdown timer in this case. It can be count up or count down or count up down timers. This countdown timer comes under these combinational circuits. So you should know how to design the counter actually, but of course that's not important now. So this one has 24-bit countdown timer, this microcontroller. So when reload, it initializes with the count 0. The initial value of the timer is automatically reloaded in the register. It helps to perform an operation after a specified time. So for example, now we have this 24-bit timer, right? So now let me tell you an example. Maybe I have the 4-bit counter. So what this counter will do? So this is the 0, 0, 0, 0. This is the 4 bits. This is the starting of the counter. And then it will count each clock cycle 1 bit up. So now 0, 0, 0, 1 and 0, 0, 1, 0 and 0, 0, 1, 1 and so on. And it will count up to 1, 1, 1. All the bits are 1. All the bits are 0 in the starting, and the end is all the bits are 1, 1, 1. So actually, if you look at the value numerical, this is the binary value, right? So if you look at the decimal value, this is 0 and this is 15 decimal number. So this counter will count 15 seconds. Let us say this is just 15 clock cycles, 15 seconds. So 0, 1, 2, 3 and so on up to 15. Okay, so this is called up counter. So after it reach the maximum value, what the counter will do? It will automatically reset to 0, 0, 0 again. So what will happen here? Now it will again initialize to 0, 0, 0, 0 and then start the counting again. And then after it reach 1, 1, 1, 1 and then again it will initialize. That is what I mentioned here. It will automatically reloaded in the register. The initial value of the timer is automatically reloaded. Initial value is, this is the initial value for the 4 bits counter. And if it's the 24 bits means you will have 24 bits. That's all. And this is the up counter. And we also have the down counter. Down counter means the initial value will be 1, 1, 1, 1. This is the 15. And then it will just reduce 1 by 1, 1 bit by bit. And then finally it will reach 0, 0, 0, 0. This is called a down counter, 0. Counting down, right? 15, 14, 13. And here is not like that. Here is a 0, 1, 2, 0, 1, 2, 3 and so on until 15. And we also have up down counter. So it means it can perform both operations. So here this counter can only perform up counting. So 0 to 15, and then here it's down counting, and here up down counting. So the enable bit in the control and status register is cleared. It will never stop, works even in sleep mode. Counter is always working because it's also relevant to a real-time clock. Okay, so the systic timer generates interrupt requests on a regular basis. It's not only just helping for this counting, it's also helping to generate the interrupt request. And this allows operating system to carry out context switching to support multiple tasking. So because the operating system is just working on one task, whenever the interrupt comes, it needs to process the interrupt based on the priority. And for applications that do not require an OS, if you are using this microcontroller together with your computer or some kind of operating system, then that's the different direction. But if you are going to use the microcontroller without operating system, then This SysTick timer can be used for timekeeping, time measurement, and so on. That is what the microwave oven or refrigerator or the running machine, the treadmill you are using in the training center. So all these machines they do not need the operating system. So microcontroller is a standalone unit. Because of that, the SysTick timer is used to just for timekeeping and time measurement and so on. So as an interrupt source for tasks that need to be executed regularly, yes, we can, the timer is similar to the timer and alarm clock you are using in your mobile phone. Okay, so it has also 3 modules, and it has a control and status register. As I already told you, SR, that is status register and CR, and we have the reload value because we need to reload again, and we have the current value. We have to always track the current value. What is the value in the current register? So these all are also sub modules of the SysTick. Working principle: the timer is set to an initial value, and then the initial value is decremented to 0. There is a down counter, which means that the timer is completed. After the completion, an interrupt can be generated or no interrupt can be used. So it's really up to the user or the programming nature. So you can generate the interrupt after certain time period. So, and it will automatically reset. So this is the, here you can see a small table. This is a count flag, CLK source, clock source, tick integer, enable bit, and so on. So the 16-bit or the 16th bit is the flag bit. That is what we call count flag. So this bit is set to 1 after decrementing to 0, and it's automatically cleared after reloading. So everything is about here. We are talking about the same thing. So once after it reaches this end value, it will again reload into the initial value. And the second bit in the clock selection bit, you can select the external or internal clock as the clock source. So you can select which one you want as a clock source with respect to the timer. Remember, you have the clock source internal clock, and also you have the external clock in the microcontroller. And the first bit is the enable interrupt bit. So whether to generate an interrupt after the subtraction of the subtraction ends. So this is the enable bit. So if you keep this enable bit as a 0, then the interrupt is not really enabled. Interrupt is disabled. Instead, I just make this bit as a 1, then I enable the interrupt. So it means whenever the interrupt comes, then the CPU will start to process that. It will halt the main program, and it will start to process the interrupt, and then it will jump back to the main program again.